So this type of problem is still using stoichiometry, but the major difference between a problem where you're using stoichiometry with amounts given in mole is that in a problem like this one here, where you're given amounts in grams and you're being asked to find out grams of something else, you will have to add two additional steps, one in the beginning and another one at the end of your calculation. When you have a chemical balance equation, that equation, it's relating the amount in moles of your reactant with moles of another reactant, moles of a reactant with moles of your product. But you can also use amounts in grams. The thing is that when you have amounts in grams, you will have to use the molar mass first to convert the amount given in grams to moles, so you can use the molar ratio from the balance equation. So I have here some steps, and these steps work for most of the problems, and it's in a generic form. Okay? So I will give you an example where we're going to be using steps 1 through 4 with an actual chemical equation. The first thing that you have to do is to check that your chemical equation is balanced. Then you're going to convert the given amount from grams to moles. Okay? So the given quantity is going to be in grams, and you're going to convert that to moles. And I have, that's number 2, X amount of A given in grams, and you're converting that to moles by dividing by the molar mass. So that's what you do to convert grams to moles. If it's the same substance, your conversion factor between grams and moles of the substance will be the molar mass. Once you have the given amount in moles, now you can use the molar ratio from the chemical equation to go from moles of a substance to moles of a different substance. That's what the molar ratio allows you to do. You can get moles of a substance if you have grams of that substance using the molar mass, but it's the same substance. You can have grams of water, and you can get moles of water by dividing your grams of water by the molar mass of water. But when you have a chemical balance, a chemical equations that it's balanced, you can actually find a ratio of moles between two different things. So that's what you're doing in step number 3. Once you have the moles of your given substance, you can use the coefficients in your chemical equation to convert the moles of the given substance to the moles of whatever you're trying to get. That's what I have right here. You have the moles of A, which is the given, and you're converting that to moles of B using the stoichiometry from the reaction. In number 4, if you're being asked amount of your substance, the one that you're trying to calculate in grams, you have to convert your moles to grams. So that's number 4. And to convert moles to grams, you're multiplying by the molar mass. So if this is what you're trying to find, B, and you want grams of B, once you have the moles of B, you can multiply that number times the molar mass of B to get the grams of B. So I have your 4 steps listed, and then here 1 through 4 with a generic example. Your chemical equation, balance 1 mole of A, it's giving you 1 mole of B. So if in a problem, what it's given is the grams of A, and you're trying to find out grams of B. So A and B can be anything. You can have A as a reactant, B as another reactant, A as a product, and B as a reactant. In this example, A is a reactant and B is a product. But you should think about this as A being the unknown and B being the thing that you're trying to get, not just as reactant and product. So you have your balance equation. The given amount, it's X grams of A, so I have here X grams of A, and I'm converting that to moles of A by dividing the molar mass by the molar mass of A. You don't have an actual number because we don't have an actual number for A. That will give you the moles of A. Step number 3, converting the moles of A to moles of B using stoichiometry. The one that you're trying to get is B, so I have that on top of my conversion factor. And then you have moles of A coming from this one here in the bottom part. So mole of A is canceling out with this one, and you're getting a number that is going to be the moles of B. And finally, since you're trying to find out grams of B, you have your moles of B from here, and you're going to multiply that times the molar mass of B to get the grams of B. So let's look at the steps with an actual problem. So number 1, it's checking that you have a balance equation, and usually in your problem, the problem will tell you using the following balance equation, or balance this equation and then use this equation to find out whatever they want you to find. So if the problem is not telling you that the reaction is not balanced, you can assume that it is, but you should check. 1 calcium, you have 2 nitrates on this side because your coefficient is 2, so 2 nitrates, and here you have a subscript of 2 for the nitrates, so that's 2 and 2. 1 coefficient of 2 here in front of the silver nitrate, so that's 2 silvers, and you have 2 silvers here. That coefficient is making this one also 2, so you have 2 chlorides, and you have 2 chlorides on the reactant side, so that reaction is balanced. If you don't have a number, the number is just 1. Molar masses are given for a reason. You're going to need them. Okay? Now, first thing that you have to do when you look at your problem is identifying what you have and what you need to find. In this problem, you're given 2 different amounts. Okay? Those 2 different amounts are amounts for each reactant here. And you're trying to find the mass of one of your products, the silver chloride. So if you're given amount for 2 of your the 2 reactants that you have, you want to find out mass of the product. This is a problem similar to what you have to do if you're trying to find out the limiting reactant and the theoretical yield. So you're given amount of your 2 reactants and you want to find out amount of your product, and you have to do 2 separate calculations, 1 for each reactant. So step number 1 was to have a balance equation. You have that. Step number 2 is to convert the grams of your given to the moles of the given. But I have 2 given, so I'm going to start doing everything with this one here, with the calcium chloride, and then we can move to do everything with the silver nitrate. This is step number 2. That's step number 1. I have the grams of calcium chloride, and I want to convert that to moles of calcium chloride right here. Grams of A, the given, and I want moles of A. So I need to divide by the molar mass of A. So I have calcium chloride here listed as 111 grams, so that's 111 grams per mole of calcium chloride. So that's my first step. That is going to give you a number that it's in moles of calcium chloride. And you can actually do all of these steps at once. You don't need to find these moles, then use that number to get this one. You can go from this conversion factor to this one to that one in just one step. So I'm going to do step by step with the first one, and then with your second reactant here, I'm going to do all at once. So I have my first step here, converting my grams of the given to the moles of my given, and that gives 0.54, 0.541. I'm rounding to 3 significant figures using this one, not using the conversion factor. That's mole of CaCO2. Step number 3 is to convert the moles of the given to the moles of what you're trying to get using the stoichiometry. So you're going from the grams of calcium chloride to the mass of silver chloride. It's this one to that one, and then in a separate calculation, this one to that one. So you can determine like which one is your limiting reactant, theoretical yield, even though that's not what the question is asking you to do. But for you to find out what mass of silver chloride you're getting, you need to get the mass of silver chloride that you're getting with this one and with that one before you can determine the actual answer for your question. So number 3, I have CaCO2, and I want silver chloride, that's 2 AgCl over, and this here is CaCO2. And my coefficient for that one is just 1. So that's going to give you just that number times 2. So first, converting the given grams to moles using the molar mass. Second, converting my moles of the given to the moles of what you're trying to get. That's number 3, 2 and 3, sorry. And then I have one more, which is going to be, because you're trying to get the mass, right? This number here, it's moles, so you're not done. Times the molar mass of the one that you're trying to calculate. So this one is here. You have moles of B, which is what you're trying to get, and here you have the molar mass of B. In this case is your silver chloride over 1 mole, and that will give you the grams of silver chloride. This should be 3 significant figures, so that 2 should not be there. It's just 3 sig figs. Okay, so step 1, 2, 3, and 4, and that's just with the calcium chloride. And this is the amount of silver chloride that you can get with this amount of calcium chloride. So all of this here is your calculation for the first reactant, that number, but you have 2 of them. So for the second one, I'm going to do this all at once. You can do one way or the other, it doesn't matter. You might get a different answer by, like, it will be different by decimal places or by a super small amount, and you don't have to worry about that. So I'm starting with my given 80 grams of silver nitrate, and the first thing that you have to do is to convert your 80 grams of silver nitrate to moles of silver nitrate by dividing that number by the molar mass. So I have my molar mass here, That's my first step, and I'm going to keep going. My second, right, will be converting this number here in moles to moles of what you're trying to get, which is the silver chloride. So using the stoichiometry, this is 2 moles of silver chloride. And for the silver nitrate, you have a coefficient of 2, so that's 2. And then the last one, it's converting the moles. Look, you can check how the units are canceling out. This is grams of silver nitrate, and this is grams of silver nitrate because that's the molar mass for silver nitrate. So grams is canceling out with grams. What you have here, it's moles of silver nitrate because that's the molar mass for silver nitrate. So mole is canceling out with those moles. The number that you have so far here, it's a number in moles of silver chloride. And what you're trying to find is the mass of silver chloride. So you're missing the last one here, which is multiplying times the mass of the silver chloride, which is 143.3 grams for every mole. Mole of silver chloride, because this is the molar mass of silver chloride, so this one is canceling out with that one. And what you're getting is a number that it's in grams. And since this is the molar mass for silver chloride, that number is grams of silver chloride. And rounding to 3/6, I get 67.5. Okay. So this here, it's the amount of silver chloride that I can get with my reactant silver nitrate. So I have two reactants, 2 calculations. Your calculations are the same thing. You're following the same steps. You're converting the grams of your given to the moles of your given using the molar mass. Then those moles you're converting to the moles of what you're trying to get using the stoichiometry. And finally, once you have the moles of what you're trying to get, you're converting that to grams using the molar mass of that substance that you're trying to find. 2 reactants, 2 calculations, 2 different amounts for silver chloride. So whenever you're trying to determine which amount of product is the actual amount that you can get, or the theoretical yield, right, it will always be the smallest number out of the 2. You have plenty of calcium chloride to get all the way to 155 grams of silver chloride, but you have enough silver nitrate only for 67.5 of silver chloride. So you cannot get 155 because you don't have enough of this one, which is required for you to get silver chloride, right? You have enough of this one to get this amount. So you cannot form any more silver chloride because you're using up all of the silver nitrate. So in this example, your silver nitrate will be the limiting reactant. And even though the problem didn't ask you to find out those things, this is a type of problem that it's about limiting reactant and theoretical yield. Your calculation is always the same thing, but you need to know that out of these 2 amounts, the smallest one is going to be your theoretical yield, because you cannot form any more silver chloride due to the fact that you don't have enough silver nitrate. So this number here, it's your theoretical yield. So a modification of this type of problem will be for me asking you, okay, what is the theoretical yield of silver chloride when 60 grams of calcium chloride are reacted with this amount of silver nitrate? That's another way of asking you to find the same things that you found in this problem. So this is a problem for you to solve on your own time. You have the molar masses here. The reaction, it's balanced. You can check, but it's already balanced. And then I have four things. For the first calculation here, you're given grams of your tetraphosphorus decaoxide, and you should practice your names for your formulas because that's part of the exam. And you have that amount in grams, and you're trying to find out moles of your product here. Okay? So this is not grams to moles, but the given it's in grams, and you're getting moles of your product, assuming that you have an excess of the water, which means that that water is not limiting the amount of products. The amount of product in this example will be limited by that amount of reactant. In the second one, you're given grams of a reactant again, and it's asking you to find out the mass of your product. Okay, so now you're going from grams all the way to grams, and again you're assuming that you have a lot of water, so you don't have to worry about that one limiting the amount of product that you're getting. In the third one, you have grams of your product. This is what you have, grams of this one, and you're trying to find out grams of the water. Okay? So the given in grams, and you need to find out the one that you're getting, it's also in grams. And the last one is a problem that you need to do the calculations that you have to do to find the limiting reactant and the theoretical yield. So that's why I'm writing down those two here. So whenever you finish your calculation, that should be your answer. And you should identify which one is your limiting reactant, which one is your theoretical yield. And you have the answers, and you can check everything that you're doing with what it's in here.